line defects, which is known as one-dimensional. Okay, so keep in mind the other names which is common in material science. So line defect is also known as one-dimensional. So what this is, the deception involved in a row of atoms known as a dislocation. Okay, look here. Yeah, see here. This line coming out in this way. This should come like this, and this should be in this way. This should be this way, and this one. So if everything would be perfect, then this yellow line must have been followed. Okay, but here, as you can see, one of the line, which is, you can say this one, is missing from their own way at the mid of. I mean, half of the row is in their own way, but uh, just half is missing. And why they have missed? Because near about the row or column here, it is in the form of column right now. Okay, is missing. It's deviated from their own position. It must, this line, if you say, this must be followed this way. Okay, but they have deviated from left to right, and a little bit curved shape has been taken by this column. Similar to this right hand side column also followed the same way, and they have deviated from their own path towards the left, from right to left. So that's why there is a missing. Okay, so this is a line defect. As you can see, the atoms is missing in a line form. Okay, as you can see here. This line is missing. Okay, this line is missing. That's why, I mean, all the atoms that was actually filled at this position, this position, this position, this position, they are in the form of line. I mean, the atoms missing from their position is in the form of line. That's why it is known as the line defect. Okay, similar to that, this is also the same thing, but they have the negative and positive. What there means? Okay, look here. Here you can see one of, here it is a compressed, right? Here's a compressed, and here is a tension. Okay, so the region where the compression is occurred, okay, and the region ongoing tension. I mean, some, I mean, at the top you can see here it is in the form of compression, and here it is in the form of tension. Okay, so similar to this is also the same thing. Okay, but this is just a placement. Okay, how they have placed. Okay, so the same figure, you can just think about, they have, you have just, you know, flip the figure. Okay, the top position come to the bottom, and bottom has come to the up, come to at our top. Okay, just similar to that, if you know the compression side is at the bottom, then it is known as negative edge, and at the top, then it is known as negative, positive. Okay, so this is just a line defect. You can think about a similar, I mean, you have a just a kind of small balls are keeping in the form of line. Okay, and one of the line has a half is completed and half of the line is missing, and that's why you have just compressed at the nearby lines. Okay, to look a little bit, fill the space. That's why that kind of the uh, empty space is known as edge dislocation or line defects. Okay, here's the definition. Okay. So line defect or dislocation are abrupt change in atomic order along a line. As I have told you, as I have shown in your figure, the line has a disruptions. Okay, they occur if an incomplete plane inserted between the perfect planes of atoms, or when vacancies are aligned in a line. Okay, vacancy in a point defect, we have discussed what the kind of thing is known as a vacancies. Vacancy means simply the atom has removed from their place and no other atoms has filled that space. So there is a vacancy. Okay. So it is the kind of the vacancy. Okay. And but in the form of line. I mean, uh, uh, in a regular fashion, in the way of line, more atoms are missing from their own place. That's why there is a kind of vacancy, and that vacancy is in the form of lines. Okay, the space that is vacant is in the form of line. Okay, so a dislocation is a defect responsible for phenomena of slip. What slip? I will let you know further. Okay, just for now, you just think of normal slip. Slip means that the something that has moved away from their own space, own place. Okay, here as you can see. Okay, I mean this line must follow this way. Okay, but they have slipped and come to here. This line must follow this way, but they have slipped and come to here. So this is the kind of slip. Okay, slip is a topic we will discuss later on, but for right now you just understand that slip is something which is displaced from their own position and have followed or occupied the nearby position, that is another slip. Okay, simple. So, I mean, if everything would be perfect, then this line must follow this way. Okay, but due to the slip, and there is a vacancy, so they have slipped from here to there. I mean, this point has come to this way. Similar to that, here also the same phenomena has occurred. They have come here, so this is the slip. They have moved from one way to the other way. Okay, it is very near, so this is slip. Okay, by which most metals deform plastically. Okay, so I mean the deformations are of two kinds, elastically and plastically. When you apply the load, not a stress. Stress is an internal phenomena. We cannot apply the stress, we can apply the force, we can apply the load only. Okay, once you apply the load, okay, due to the load, the material property inside the material which we cannot see, that resists that force. Okay, and resistive force per unit area is known as stress. Okay, so in general we can say we mostly think that whatever the force that we have applied is known as stress. No, that's not the stress. Stress, I mean, when you apply the force on a body, the body try to resist that force, and that resistive force by the body is per unit area. If that is per unit area, that per unit area of resistive force is known as stress. So stress is an internal property of material. Okay, so more or less you were right. Okay, so whenever you in a layman term you can say that it's a stress, but it's not a stress, it's a force, a load. When you apply the load, then, the body, if after releasing the body load, the body comes to the original position, then it is a plastic deformation. For elastic deformation, I mean they can regain their shape, they can regain their position. Okay, after reducing the load. Okay, and in plastic deformation, once you applied the load, they will, and if they have deformed, then they will not regain their position. That is known as the plastic deformation. So you were right, but just correct yourself. I mean, it's a load, not a stress. So stress, what is the difference between the stress and load? Load you apply. I mean, external things that you can apply on the body, but stress is an internal property of internal things which is going on inside the material. So it's a material property or material things that you cannot apply. But yeah, but why we call this as a stress? Because the applied force is basically equal to, you can say in a good way, that the resistive force by the body is equal to the applied force, more or less, or up to elastic limit where he can regain their shape. Okay, that's why we can directly correlate this. But the real term and the correct way to say is the load is the external things that we apply, and the stress, the material induce in itself due to the applied load. Okay, got it?
Okay, okay, sir. Yes,
Yeah.
got it, sir.
O- Okay. So here what is by slip? You can see here it is a plastic deformation. It means that due to the slip, we can not get this real position or real shape as it was originally. So here plastic deformation occur, and plastic deformation is not desirable in engineering things. But more or less. But you can think about the production engineering, okay, where we have the main target of plastic information, because we are machining the materials. When you are machining the materials, it means you are removing the materials, and removing the material is required to the plastic informations, so they cannot regain their shape. We simply cut the surface, and we want to remove that particular material from the top of whatever the kind of the shape that we are required to make. Okay, according to that, we basically do the plastering formation. So overall, in a production engineering, we are concerned about the plastering formation. So it depends on your priority, on your application part, what the kind of application that you have. More and less, most of, if you talk about the engineering application, like if you have made any kind of equipment, or the if you have made a structure or buildings or bridge where we cannot uh, bear the plastic formation. Okay, there could be a elastic deformation that would be desirable, that would be tolerable, we can tolerate that. But the plastic deformation, that we cannot tolerate. Okay, but in machining part or in a production part, that we basically concerned about the plastic deformation actually, so that we can get the desirable product. Okay, so keep in mind. So it's, I mean, all the times a plastic deformation is not undesirable. Sometimes it is desirable. It depends on your application part. Okay, but in this case, it is a desire. If we are looking at the kind of the material which is the final product, then it is undesirable. But if this is going to be happen in a a production part, then it is desirable. But here we are talking, this is an undesirable part. Okay, so it is a plastic deformation, because we are studying the defects. Defects means which is something which is not desirable. Okay, so this is the reason phenomena. This is the reason of slip by which the plastic deformation occur. If this is the, I mean, this is the reason. Okay, and this is the consequences. What the kind of the consequences that we get due to the slip. Slip is a phenomena, and the consequences is the plastic deformation that we are not concerned about. I mean, we are not desirable. We are not think of being this. Okay, that's why it's undesirable. Okay, so it occurs in high densities. Okay, density is very high, and are immediately connected to almost all the mechanical properties, which are in fact structural sensitive. What I mean, this is, I mean, where the material density is high, and the due to this misalignment or dislocation, we basically get affected all our the mechanical properties, and this is obvious. Okay, if you have you have a memory of last class that we have discussed about the line point defects. Okay, so similar to that, you can think about it. Wherever the dislocation is, line dislocation or line defect is present, there must be uh, you know mm, uh, deficiency of atoms. Okay, and if deficiency of atom is there, it means their properties will get affected. Okay, so obviously it would, mechanical properties will get deviated from their original one. Okay, so which are this one. Okay, so dislocation form during the plastic deformation, solidification due to the thermal stress arising from rapid cooling. Okay, so where it can occur, as you can see, the rapid cooling where you can see, I mean, you have heated the material. Okay, and then you have quench it. Quench means, I mean, you have just put that material into the water, so that your material will get cooled down very, uh, you know, uh, in a very little time. Okay, so how you can, I mean, that process is known as the quenching. So quenching is kind of the rapid cooling. Okay, I mean, there are lots of other way you can heat the material, and then you can release them in a different way to cool down the material. Okay, and different methods will define your stress phenomena inside the material. Okay, so if you think about the thermal, I mean, one of the method is annealing. Annealing means you have heated the material, and after certain temperature, I mean, whatever the desired it was, so you have reached that temperature, and then you have left that material to cool down in an environment or environment temperature. So what you will get, that kind of the cooling is known as annealing. And if we talk about the quenching means if the same temperature you have raised, okay, once, and then you have kept kept that material into the water, okay, so that they can reach their normal temperature, they can cool down very easily or very fast, okay. So that is the way, I mean the same temperature you have raised for the same material, but you have followed the different way to make them cool down, and that the different way will decide what the kind of the stress is present in your material, okay. So here the solidification could be of different kinds, okay, and due to the thermal stresses arising from the rapid cooling. So rapid cooling की वजह से क्या होता? Then we have the stress, and stress will generate stress would be of different kinds when it depends on your the way that you have followed to make them cool, okay. Solidification simply means making them cool down, okay. So solidification basically is just not a cooling. I mean, if you have molted the material, okay, or the solid, molten means you have made that particular material to the liquid form. And then now you are allowing them to cool down, okay, to make them. If that, I mean, the temperature will decrease, then obviously it will get converted into the solid again. That is known as the solidifications. Okay, so edge dislocation. So an extra half plane of atom is inserted into the lattice, as you can see here. Okay, so causes lattice strains around the defect. Strain means strains. I mean, there is a stress and a strain. Strain means the elongation or the change in their position by the original positions. That is known as strain. Okay, so as you can see here, this was the. I mean, if you will find out the stress strain, then it would be like the how they have deviated from the original position, and I mean stretch amount, I mean the elongation, how much elongation they have made, and how it was at originally. That's the ratio of these two is known as the strain. Okay, now come to the screw dislocation. What is screw dislocation? Simply same as atoms are displaced along a helical path, okay, around the defect line. So the defect line is there. Defect line is, this is the line defect. Okay, so this was just a edge dislocation. So after edge dislocation, or you can say dislocation, the material will screw. Screw means the movement, the helical path, or you can say little bit slip. Slip is, as you can see here. If everything would be perfect, then this line must be shown. This, this, and this straight way come to up here, and then this. This was the original. If everything would be perfect, but as due to the dislocation, this part, this half, as you can see, this part, this part has moved a little bit. Moved is in the form of a screw. So this extra part has deviated. This is a deviation. As you can see here, this is the less. Here it is perfect. Okay, but as they are moving away from this line, they are having the more space in between. This is the space. You can think about, it's a step, kind of a step. You can put your foot over here, kind of. Okay, so this is a kind of screw dislocation. So once the uh, dislocation occurs, and due to this dislocation, the material will move, or take a dislocated from their own path in a helical way, as you can say, in a circular kind of things. Okay, so they have moved a little bit, as you can think about the uh, Sudoku, right, where you can move. If you have half of the part is at the same at the bottom, and you have just moved up little bit of half of the part of above, that is the kind of the things. Okay,